Hello students of calculus, it's Professor Gubser, and today we're going to have a little tutorial on a use of the derivative for finding the extrema. We've done this a little bit before, we'll explore it more deeply today. So I'm using a new tool, a little touchpad screen, so we'll see how this goes. So first of all, we're going to start with a function. So let me try to draw a function here. And I'm going to have a little issues trying to get things going. So here's our function. Now I'm going to draw not y, but y prime here. Okay? Or better yet, I'm going to draw y equals f prime of x. Okay, that's what we're going to show here. So here we go. I'm just going to make a little simple graph. There's that. We'll put some tick marks on here. 1, 2, okay. So now the question I want to ask is, where is f of x increasing? That's the question we want to answer. So if you recall from this, we want to look at the function and determine where the function is increasing. We want to look over here and find out where the derivative is positive. So that's not too hard to do. We simply look at the graph and we see anytime the graph is above the x-axis, we know that the function is positive. So in this case, we would see that it is increasing between -2 and 3, decreasing at the other sections. Okay? Does that make sense? So let me add to this a little bit, okay? Let's say that our function here, let's extend these lines a little bit. Let's say that our function stops right here at -3 and at 5. That's its domain, from -3 to 5. Okay? So let's talk about where we find the extremes of this function. What are the extremes? Well, we see here at x is 3 something special is going on. The function is, let's get another color here. Let's try to roughly draw the function. The function is increasing from -2 to 3. So it's going up, but once it gets here at -3, the derivative is negative, so the function is decreasing, so it's coming down, and the function stops at 5. Over here, we see that the function is decreasing between -3 and -2, so we want to draw a function coming downward towards this, so something like this, and we see it stops right here at the end point. So what do we see? We have some extremes here. We have a high point here, a low point down here, another high point, and a low point. So our extrema, we have local minimum at the point, that's supposed to be an at x is equal to 5, and also at, where was it? At -2. Whereas we have a local max at x is -3 and at x is 3. Okay, so we see these local extrema occur at the endpoints and also where we have the derivative equaling 0. Okay, so that's what's going on. That's what we'll be investigating. I'm sorry about that. But good luck to the volleyball team. Okay, thank you, Sherman Dean. should have turned off my email. So now let's look. Okay, so let's look quickly at an example from an algebraic rather than graphical perspective. We'll begin with the function. Function is 1/3 x cubed minus 2x squared minus 96x plus 5. And our goal here is we want to find the extrema on the interval, so only for these x values, between -10 and 25. Okay? So to find the extrema, we want to first find out where this is increasing or decreasing. So to find that, we'll look at the derivative. Derivative is x squared minus 4x minus 96, which you might not recognize right away, but I've done this problem. I created this, so I know that this factors into x minus 12 and x plus 8. Okay, so right away we can tell that we have a horizontal tangent line at x is equal to 12 and also x is equal to -8. There, x is -8. Those are the only places where we have a horizontal tangent line. So these are our candidates for extrema. We also could have an extreme happening at endpoints, which are -10 and 25. Let's try to quickly graph what we've got going on here. We know at 12 and -8, so let's call this -8, and here's 12. Let's look at the derivative. We see that if we use a number larger than 12, the derivative would be positive, which means our function would be increasing. So I don't know if it's up here or down here where it is, but we know that the function is increasing once we're past 12. If we use a number between 12 and -8, we would see that the function is negative, or the derivative is negative, so it would be decreasing. So something such as, I'm having trouble now, there's decreasing, something like that. So decreasing and then increasing up there. Graph up a little bit. There, so it looks something like that. And if we were below -8, like at -10 for example, we'd see both terms are negative. Both of these terms would be negative, which would say that the function is increasing, so it's coming up like this, perhaps. Right away we can tell something about this. We can see that at -8 we have a maximum, a local maximum. At 12 we have a minimum. We could see at the right endpoint that's going to be a high spot, so that's a maximum. And at the left endpoint we have a minimum. Now the question is this spot, is this y value truly lower than the y value at 12? Well, we have to find the y value by plugging in. We plug in x is -10, plug it into our function up here, and when we do that, we see that the y value when x is -10 is -431 2/3, and the y value at 12, that's the only other place where we can have our very lowest point, is -859. So you see the way I've depicted the graph is not accurate for what it is. This value here, this low spot here, is really much lower than the endpoint over on this side. Okay, the graph I've drawn just illustrates where we have the low spots, where we have the high spots, doesn't indicate which one, how they are in relation to one another. So we see that we have the absolute minimum at x is 12. And it's, well, actually, it's much better to describe that as the point. It truly is a point. So we see that we have an absolute minimum at 12 comma negative 859. Likewise, if we were to plug in the y values for -8 and the endpoint of 25 so that we could compare them, at -8 we have 474 and 1/3. Of course, I've already done this, so that's why I know what those are. And the y value over here, at the value of 25, the y value is 1563 and 1/3. I'm running out of room here. So we see that the absolute maximum occurs at this point. So the max is at 0.25 and 1563 and 1/3. Okay, so using the derivative together with these endpoints, we're able to identify where we have the absolutely highest point on the graph and the absolute lowest point on the graph. Okay, we'll explore this more in Friday's class. Thanks very much and have a good evening.